Hey everybody, welcome back. This is Mr. Carey coming at you again with finally video 3 of 3 of our chapter 6 review / test. And if you've made it this far, congratulations for sitting through about an hour of me droning on and on and on about fractions. But good news is we'll be done with this video and move on to, well, chapter 7 is actually more fractions, but it's a lot more fun adding and subtracting fractions. So without any more fun little quips from me, I will leave you with, actually I'll start off with a joke. Kind of more of a play on words, but did you all know that with regards to fractions, there is a fine line between the numerator and the denominator? Ha ha ha. Good old fraction joke there. That's all right. You know, only 5 out of 4 people are going to get that joke. Another fraction joke. Anyway, you all didn't come here to listen to me and my stand-up comedy, so let's go on with our math work. All right, Sandy is ordering bread rolls for, again, yeah, great, Sandy, thanks. But really, 3/5 of the rolls to be whole wheat, okay? And then what other fractions can represent the part of the rolls that will be whole wheat? Okay, so to understand this, remember, let's look at 3/5. And this, my numerator, are number of whole wheat, right? And then my 5, total number of rolls. So as long as we understand that, right? Remember, 3/5. 3 of my rolls are going to be whole wheat. 5 of them, that's my total number of rolls. Now, 3/5 is the simplest form, right? I can't divide 3 into 5. I can divide 1 into them, but it doesn't do any good. So 3/5 is as low as I can go. All right, well, let's start this off then. We have 3/5, and now they want us to, what other fraction? So I have a fraction here, and I have a fraction here. Now, unfortunately, we have to draw and shade in the models. 25 is going to be kind of tough. Basically, you just have to make 25 boxes, little strips here. I'm not going to guarantee that I can do it. But before we do that, let's figure out, before we even start drawing anything, let's figure out what this means. Well, I have 3/5 and then something 25ths. Well, what's my relationship between 5 and 25? 5 times what gets me 25? Sure, 5 times 5. That means I need to do this. 3 times 5 gets me 15, which means 15 rolls are going to be whole wheat. And then for this one right here, you just have to come up with a fraction that is equivalent to 3/5. Now, I personally, for the sake of drawing, I like to keep it pretty simple. So I'm just going to multiply them both by 2, right? And that's going to give me 3 times 2 is 6, and then 5 times 2 is 10. Much easier for me to split apart into tenths than it is to 25ths. So now we have our fraction here. We have 15 25ths, and we have 6 tenths. So I'm going to start off with drawing my 6 tenths first, because that's a little easier for me to. So I draw out my lines, and I'm going to have to really make a really fine point here. So I've got my there, and see, even that I've already started to mess up. Now again, if you're doing this on the test, you know, it doesn't have to be perfect as long as your teacher can see that you know what you're doing, right? So clearly I have 1, 2, 3, 4, 5. Now to make tens, I'm just going to split each of these in half. Okay? Just like that. And then now I'm just going to shade in 6 of them. And I'm going to use black because that's what we're using. So there's 1, 2, 3, 4, 5, 6, right? So 6 of my rolls are going to be whole wheat. And then the other 4 are going to be whatever. Who knows? Pumpernickel, maybe white bread, maybe some sort of new kind of bread we don't even know about yet. All right, now 25ths is going to be kind of tough. So what I'm going to do is I'm just going to start drawing, and hopefully I can get to a point where I can do 1, 2, 3, 4, 5, 6, 7, 8. I mean, I'm not even going to be able to do 25ths here. So if you have like a really fine pencil and you can shade in, I'm going to shade in probably the same, right? Because they're equivalent fractions. So as long as you do something, if you do something like this, right? If you have a teacher that counts up these individual strips and say, well, you didn't draw 15, well, then I can't do much about it. But the whole point of this is to show your teacher that you recognize that 3/5, 15 25ths, and 6/10 are equivalent fractions. And there you go. Okay, let's move on to 15. Angel has 4/8 yard of ribbon, and Lynn has 3/4 yard of ribbon. Okay, again, I'm going to highlight 4/8 of a yard of ribbon, 3/4 of a yard of ribbon. Do they have the same amount of ribbon? All right, so now we're going to shade in, and I'll just use black to shade in. So Angel's ribbon, he has 4/8. So let's go and do this together. There's 1/8, 2/8, 3/8, and then I'm to 4/8, which is also, what is 4/8 also known as? Yes, if you said 1/2, you would be absolutely correct. Okay, well now we have to shade in Lynn's ribbon. So Lynn has 3/4. So let's count it together. 1/4, 2/4, and 3/4. Okay, so we just have to answer the question here is, do they have the same amount of ribbon? Okay, clearly we can look at this and say, no, they don't have the same amount. And so all you're going to do is just write what you see. No, they do not have the same amount of ribbon. And then say something to the effect that Lynn has more ribbon, 3/4, than Angel, who has 4/8 of a yard, which I can rewrite as 1/2. I know that 3/4 is greater than 1/2. So with that kind of answer, you are showing me that, one, you understand the model, right? You understand that you can shade in the model and you can visually look at 4/8 is less than 3/4, 3/4 is greater than 4/8. But then by saying that you have reduced 4/8 into its simplest form, 1/2, you show me that you now know how to reduce fractions into the simplest form, which is, and then by comparing fractions, 3/4 and 1/2, you're showing me that you understand the relationship. So there's a lot going on with this answer than just, no, they don't have the same amount of ribbon. Okay, so let's move on. I gotta move this up a little bit. It means I gotta move my words here because I started moving stuff around. There we go. Okay, Ella, now we're still with yards of ribbon, okay? Ella used 1/4 of a yard of red ribbon. Fill in each box with a number from the list to show equivalent fractions. So we're just going to do our translation here just so we kind of fully understand what number 16 is asking us. So translation, find equivalent fractions of 1/4. If you can't read that, I'll move it down here. Find equivalent fractions of 1/4, right? That's all we're doing, right? So if you look at these numbers, and I don't want you to pay attention to really the numbers yet. You have all your numbers here, 2, 3, 5, 6, all this. I don't want you to get confused by this. I want us to look at, if we have 1/4, and this is going to fill itself in. So let's look at this. 1/4, so 4 to 8 is what? 4 times what is 8? 4 times 2, which means 1 times 2 is 2. All right. I'm going to erase that, clean this up a little bit. So 2, right? 2 is gone. Perfect. Now, how do we get from 2 to 4? 2 times 2 is 4. That means 8 times 2 is 16. Boom. Now, we have to use some more equivalent fractions, right? We have to look at this and go, well, how can we, we can try 4 times 2, which would give us 8, And then 16 times 2 would give us 32, but we don't have an 8 or a 32 here. So unfortunately, we can't do that. We have to use the numbers we have here. And so what we can try is, we did multiply by 2. Now I want you to look at the relationship here. 1 times 2, I'm not even going to put arrows, right? I'll just show 1 times 2 is 2, and then 1 times 4 is 4. Well, what number are we missing that would be really easy to multiply that we could probably use? Now, if you said 3, I would agree with you. I'm going to use 3, right? 1 times 3 is 3, and we have a 3 there. And let's try this. 4 times 3 is what? Is 12, and we have a 12 here. So that works. That's perfect. So we can scratch that out, and now we have our answers. 1/4 is equal to 2/8 is equal to 4/16 is equal to 3/12. So that's pretty cool, right? Now, you're probably wondering, but Mr. Carey, why did they give us all these extra numbers? Well, because you could use the extra, you could use 5/20ths if you really wanted to. How do I do that? Watch this. 1/4 times what gets me 5/20ths? 1 times 5 is 5, and that means 5 times 4 is 20. So you could have done 5/20ths. And that's really all that you're going to be able to do, right? So if you did 3/12 or 5/20ths, that's fine. 6 wouldn't work, and 15 wouldn't really work here. Awesome. So there we go. There is page 275. And let's go ahead and do our last page. Oh, got to get rid of that. And one more. Boom. All right. Last page. We're going to make it through. Trust me, we will. And this should be page 276, and boom, there it is. Okay, let's finish this up. Okay, Frank has 2 same-size rectangles divided into the same number of equal parts. Okay, meaning Frank has these 2 rectangles. They're exactly the same size, but they're divided into different parts, right? The same number of equal parts. So what does that look like? Well, one rectangle, right? One of these, and I'm going to put the number here. One of these rectangles is 3/4. We're going to illustrate 3/4, and then we're going to illustrate 1/3. Okay, so 3/4. I like drawing in quarters because it's kind of easy. You just split it in half, and then you split the half in half, and that gives you quarters. And then now we just shade in what is 3/4, right? 1, 2, 3. How many parts could each rectangle be divided? Okay, now this is 1/3. Now I'm going to show you, I'm doing this, but the problem is it's going to be different, right? And I just want to illustrate this to you. So here's 1/3, right? 1/3, and then, oh, see, I got a little ahead of myself, 1/3. Now, the problem is this is not what they're asking. I'm just showing, I'm illustrating this to you. There's 1/3, okay? They're not asking you to do this. I did this to kind of illustrate that many of us would start to do this, right? And then you'd be like, oh, cool, I did it. But if you did that, that's wrong. Don't do that. What I want you to do, we're going to read very carefully. I'm going to highlight very carefully, okay? 2 same-size rectangles divided into the same number of equal parts, meaning translation. Let's do my this is one where you would really need a good translation. Fortunately, I'm a good translator. So, translation. Make 3/4 and 1/3 have the same denominators. That's it. Make them have the same denominators. That's all you're doing, because you need them. Remember, 2 same-size rectangles, and they're divided into the same number of equal parts, meaning your denominator needs to be the same for both fractions, right? They both need to be, I'm going to put x. They have to both be the same. They have to both be x. Okay? Well, so how do we figure out the same denominators? Now, what's another word for same denominators? Many of you are saying, well, Mr. Carey, don't you mean common denominators? And I would say, yes, common denominators. That's it, common denominators. So, how do we find our common denominators? Remember, we have to find our lowest common multiple or least common multiple. So let's do that. Do this in least common multiple. So we take our 3, we take our 4. All right. Let's do, well, what's our least common multiple? Let's do 3, 6, 9, 12, 15, 18. We'll do 4, 8, 12, 16, 20, and I think we're good with that, okay? So what's my least common multiple, lowest common multiple? Right, it's 12. So into how many parts could each rectangle be divided? So it's going to be divided into 12 parts. So what that means, what we're saying is 1/3 times what gets me something over 12. And then the same thing, 3/4 times something gets me something over 12. So let's just look at the relationship. 3 times what gets me 12? Sure, 3 times 4, which means I have to do the same thing to the top. 1 times 4 is 4. 4 times what? 4 times 3 is 12. That means 3 times 3 is 9. So now, using these fractions, we can divide them into 12ths. And here's, unfortunately, dividing things into 12ths is not something I'm really good at. But you start off by drawing into thirds, right? And so now we're into thirds. I know they don't look equal. Okay, I'll be a little... There we go. That's a little better. And now you cut that into half. So now I have 6. 1, 2, 3, 4, 5, 6. And then you cut that into half, which will give me 12. So now you can see it's very difficult to do this unless you have a ruler. And if you do have a ruler, you can try this out. But now you're just going to kind of show... and I'll shade it in black, right? So 4, and I'm going to write here, just to help me out, 1/3 is equal to 4/12. And then this one I'm going to do 3/4 is equal to 9/12. Just kind of keeping my facts straight. So I know I'm going to shade in 4 boxes. 1, 2, 3, 4. Yeah, that's pretty good. 1, 2, I can't even count my squares. 1, 2, 3, 4... Looks like 5, 6, 7, 8, 9. Okay, that's pretty good. And again, if it's not equal, that's fine. As long as, if you have something like over here, and even if you have like a really bad drawing like Mr. Carey did, I think it's fine because you're just illustrating that you know how to find a common denominator. Now, is there more than one answer? Let's go to part B. Is there more than one possible answer to part A? Is there more? Well, of course there is, right? Yeah, I could, if I really wanted to, I could, I don't know. Could I multiply them by 3? Could I multiply them by, 10? No, not really. I have to figure out, see, unfortunately, it's not as easy as making equivalent fractions. So, because no matter what I do, right, if I multiply 1/3 times 3 and 3/4 times 3, I'm not going to get a common denominator. So what do I need to do to find more common denominators? Well, I need to find more multiples. So then I would go 18, 21, 24, and then 24, right? So 4, 8, 12, 16, 20, 24, 3, 6, 9, 12, 15, 18, 21, 24. So then I have another common multiple, which is 24. So yes, I could set these in 24ths. I could break this up into 24ths, right? Something over 24. I don't really want to do that. But again, we don't have to. They're just asking us, is there another possible answer? Then you just need to say yes, right? There, of course there is. I could set this to whatever I want as long as the denominators are common denominators. And then how do we explain that? Well, you say, yes, there is more than one possible answer. I can find more common multiples and divide the rectangles to represent the common multiple, which will become my common denominator. So that's the first part of the answer. Then the next part is, what's the next part? Did you find the least number of parts in which both rectangles could be divided? Yes, we did. That's the first thing we did. Yes, I found the LCM, least common multiple, which was 12. And then I think that's fine. Like if you, I'm gonna do this in yellow to really highlight, right? So if you have your decent drawing here, you factored out, did your least common multiple, and you have an answer like this, it's easy for a teacher to look at and go, yes, I can look at this and know that I understand, that you understand, that we all understand how to do fractions. And find the least common multiple, how to find common denominators, etc., etc., etc. Okay, we are on the last problem here, 18. 18A, B, and C. So, let's finish this up. Suki rode her bike. I'm going to highlight. We'll do green this time. 4/5 of a mile. Claire, I'll do Suki in green. And then let's do Claire in yellow. Claire rode her bike a 1/3 of a mile. They want to, and I'll do this in red, they want to compare how far each rode their bikes using the benchmark 1/2. So, what you can do is all you're doing is looking at, you don't even have to draw the number line, right? You can if you want. I'm not going to this time. So you're going to compare Suki's distance, right? So 1/2, remember I'll highlight my benchmark in halves, right? That's my benchmark. Here is Suki, 4/5, and Claire is 1/3. So now we're just comparing, okay? So 4/5, is that greater than, less than, or equal to 1/2? Okay, so my first question is when you're looking at a fraction and doing a benchmark, okay, what is half of 5? All right, if you're not sure, what's half of 4? Half of 4 is 2. Half of 6 is 3. So what's in the middle of 2 and 3? Middle of 2 and 3 is 2.5, right? So if I wanted to, I'm going to write this kind of, half of 5 would be 2.5 over 5, right? It's not really how we wouldn't write a fraction this way, but this is to show you that half of 5 is 2.5. So my question is 4 greater than 2.5? Yes. So is 4/5 greater than 1/2? Sure. 4/5 is actually very close to 1. So we're going to write 4/5 is greater than 1/2. Now let's look at Claire, right? Now, this is, I remember I told you, I believe it was last video, that I'm going to show you a little thing with common denominators and common numerators, okay? And I'll do that at the end of this. But I've got 1/3 and 1/2. Well, I know 1/2, right? 1 is half of 2. Well, what's half of 3, right? So if I have 1/3 and I want to rewrite thirds as a half, it's basically going to be 1.5. 1.5 is half of 3. So because 1 is less than 3, I'm going to write 1/3 is less than 1/2. So then, using my benchmark, Suki, did she write a longer distance, the same distance, or a shorter distance? Well, because Suki's is greater than 1/2 and Claire's is less than 1/2, we know that Suki wrote a longer distance than Claire. Now, that takes us to the end of our third video. Now, I'm going to delete all this. because I want to tell you something about common denominators and common numerators. Okay, so I'm going to type this. I shall write it here. So if I have common denominators, let's do, I don't know, I'll pick tenths, right? If I have 2 tenths, and then I have, 7 tenths, right? I'm comparing these fractions, okay? So in common denominators, let's put this up here. Common denominators. Common denominators. When the larger the numerator, the greater the fraction. Pretty cool, right? Now, why is that? The larger the numerator, the greater the fraction. Now, this only deals if I have the same denominator, right? Because this is saying if I have tenths, right? I've cut my, I don't know, let's do this. I've got a pizza, right? And watch this, I'm gonna do some magic here. And I've got my circle, and I go bam, and there's my other circle. Pretty cool, right? So if I'm doing a common denominator, that means I've divided this into tenths, which I wish now I would have picked a different fraction, because I'm not really good at dividing into tenths. I don't know. You know what? I'm gonna change this into something I can actually draw really well without people making fun of me. So we're gonna do this into eighths, right? I like eighths. I can draw 8. Okay, let's do eighths. Okay, so if I'm drawing into eighths, this says I have 2 pizzas. There's halves, quarters, and then there's eighths, right? There's half, quarter, and then eighths. So if I'm saying I have 2 eighths of something, that means I have 1 and 2, right? 2 eighths, which looks very similar to 1 quarter. Now, if I have 7 eighths, there's 1, 2, 3, 4, 5, 6, 7. Now, I'm not going to color this all in perfectly, because you don't need to sit here and watch how bad I color on an iPad. But as you can see, right, the larger the numerator, the greater the fraction, right? Because here's my 7 eighths. 7 is larger. I've cut the pizza into the same amount of slices, but I have more slices, which means 7, right, is larger than 8. All right, now what about common numerators? Okay, that's something we may not be as familiar with. So what does a common numerator mean? So I'm going to use, again, something I can easily divide. I can do thirds, right? Let's do common numerator. Let's do 2/3. I'll do it in red. 2/3, and I have 2/6. Okay. Now we need to compare these. So with a common numerator, common numerator, the larger the denominator, the smaller, the fraction. Now that's kind of cool, right? That's the opposite of common denominator. With a common denominator, the larger the numerator, the larger the fraction. With a common numerator, it's different. The larger the denominator, the smaller the fraction. And we're going to show you why that is. It's kind of a cool thing. And I'll do pizzas again. Why not? Okay, so I'm going to do, there's my pizza 1, and then a little bit of magic. Boom. There's my pizza 2. All right. Now let's divide this into thirds. I'm reasonably sure I can do thirds. Okay. And those are big slices. Now if I'm doing thirds, I can do 6s. I just cut each of these in half. Okay. And that gives me 6. So what does this mean? I have 2/3, right? So I'm going to shade it. I'll shade it blue this time just to keep things interesting. And I'll try and, so there's 1/3. All right. And let's see, I can actually make this way bigger. There we go. Really speed that up. There we go. 1/3. And then there's 2/3. Cool. Now, what does 2/6 look like? 1/6 and 2/6. Okay, now which one of these fractions is larger? 2/3 is greater, oh, really? 2/3 is greater than 2/6. So this makes sense, right? The larger the denominator, right, the smaller the fraction, only when you have common numerators. Or another way to say it, you could also say common numerator, the smaller the smaller the denominator, the larger the fraction, right? Because I am cutting it into less pieces, right? I'm only cutting this into thirds. So if I have 2/3, that's a lot more than 2/6, right? Because a sixth is like, and I'll show you, I'll shade this in green, right? I won't shade it, but a sixth is a lot smaller than a third. So it makes sense that if I have a common numerator, the larger this goes, that means the smaller and smaller and smaller and smaller pieces I'm making. So if I only have 2 slices of sixths, but I have 2 slices of thirds, I mean, that means I have a lot more pizza. So I'm going to leave you with that, with video 3 of 3. The big thing with common numerators and common denominators. I haven't used common numerators much, but I'm starting to like them. But they're a little more difficult to kind of wrap your mind around because it's opposite, right? The larger the denominator, the smaller the fraction. The smaller the denominator, the larger the fraction. But take a minute, look at this. Try it on your own, right? Try and draw out some common numerators, right? Try fourths, try fifths, try sixths. And then, pick, something that you can, I don't know, something that you can look at and pick a numerator that's the same, and then try it on your own, especially, drawing it out. So unfortunately, I have to leave you, but I will probably see you again in chapter 7. That's where we get into adding and subtracting fractions. Don't worry, it's a lot easier than it seems. You've been given all the tools in chapter 6 to successfully add and subtract fractions. It's a lot easier than it sounds. So if you liked it, like this video, great. Go ahead and like it. If you like it so much you want to leave a comment, outstanding. Leave a comment down there. If you're not sure on anything, if you need me to over-explain something, as Mr. Carey always does, I'm happy to over-explain something to you. And do another example of Mr. Carey, can you show me like just one lesson on how to reduce fractions? Be more than happy to do that. But until then, and until chapter 7, this is Mr. Carey signing off. I hope you all have a fantastic day and keep charging with your math. I kind of lied a little bit. I'm going to leave you with one quote, and this is actually something I pulled up and I liked. I usually don't like, there's a lot of quotes I like, but this one I thought was really kind of appropriate for math, right? The problem is not the problem. The problem is your attitude about the problem. I kind of like that because it's really true, right? You look at a math problem, and when you have a good attitude about it, and you're like, oh, dude, that's so easy, then you are more likely to get it done. But if you look at a problem and you go, oh, I hate this. This is hard. Oh, I hate fractions, right? Okay, well, the problem is just what it is, right? It's just words on a paper and numbers on a paper. It's not a bad problem. It's your attitude about a problem, right? So change your attitude about the problem. Say, if you don't know how to do it, say, well, I don't know how to do it now, but I'm going to learn. Or, yes, I've done this before. I know what I'm doing. Or, yeah, I'm going to try. All right. The whole point of this is have a positive, have a positive attitude, right? Have a positive attitude, and math becomes a whole lot easier. And life actually becomes a whole lot easier when you change your attitude about a problem. So again, one more time, Mr. Carey signing off. I hope you all have a fantastic day and keep that positive attitude. And I'll see you next time.